Check, check. There we go. There we go. All right, so this is live streaming today. Make sure if you want to ask a question at the end, to grab this mic right here. It'll be sitting right here. So get somebody's attention and ask them to pull it over to you. Otherwise, our live streaming viewers will not be able to hear the question you're asking, and that's important. Yeah. Oh, okay, gotcha. Just want to make sure. Ladies and gentlemen, welcome to CHADEV. And one other note about this mic: when you speak into it, don't swallow it, because you'll blow out our levels for our streaming viewers. Okay, with that, yeah. So today we got Stuart Dickerson from Unum. I don't know how to say it, and he's going to be talking about web APIs. So that'll be fun. A couple announcements first. Next week we have Colin Reimer talking about React and Redux, so that'll be a really fun talk. And let's see, the week after that, we're not going to meet on that Thursday. We're going to have a Christmas party in its stead on the 15th. So it'll be right here on floor 5. So come in for that. It'll be a fun time to hang out with all of your CHADEV friends and colleagues. Huh? BYOB. It's going to be BYOB. So, yeah, please do. 7 o'clock? 7? I think we're going to do a 7. 7 good for everybody? Anybody want later or earlier? Speak now or forever hold your peace. All right. Give a quick shout out to our sponsors that make all this possible. Carbon 5, UTC, OpenTable, who am I forgetting? EPB, thank you. Big shout out. There's one more. I'm sorry. Okay. Jeff has a quick announcement for us. So, Jeff, bring it on in.
Thanks, Brett. Hi, y'all. I'm Jeff. I work for the Public Education Foundation, and next week is Computer Science Education Week. A lot of schools across Hamilton County are going to be doing the Hour of Code through code.org, an hour-long kind of fun introduction to programming, hopefully building the next generation of CHADEVs. So we're going to ask like 4 concrete ways you could help with the Hour of Code next week. One, and I just had Andrew tweet it out over the CHADEV's Twitter, we put out a call for volunteers. If you want to send that to your networks, that would be awesome. You can volunteer yourselves, code.org/volunteer, and put yourself in the system. Stuart was one of our awesome volunteers last year. That could end up looking like answering a couple questions for a teacher who's going to be running this whole thing themselves. It could be visiting a classroom you want to visit. It could be doing a quick little Skype into a classroom and talking about yourself and what your career has been like. If you have a specific school you're interested in, send me an email, geoff@pefchattanooga.org, and I can hook you up with a school. But thank y'all for all you do in terms of education as well. So.
All right, so without further ado, Stuart, pass it off to you. Everybody give Stuart a round of applause.
I just want to make sure everybody can hear me okay? Yeah, good. Sounds like the mic's good. Okay, thanks everybody. What I want to do today is talk to you about some experiences that I've earned using web APIs in my world. Now, my world's not going to be your world, but what I hope to share are going to be some practices and patterns that would apply to anybody doing web API in their world. So just a little bit about the types of customers that we have using our APIs. We have public-facing APIs. However, it's more of a B2B scenario, so it's kind of by invitation only. So these are companies that we're asking to build out our API. We vet them first, but they range the gamut. It could be a startup with just 1 or 2 programmers all the way up to a Fortune 500 company. Also, we've seen every technology try to consume our APIs. You know, Ruby on Rails, PHP, .NET, Java, everything. So I'm always surprised at who's building these websites out there, but again, my goal is to make their experience as good as possible. Now, with a web API, what I want you to think about is not the capability or the functionality or the business service you're providing. What I want you to think about is the delivery of that. And that is what that middle layer is. That is what your API is doing. Your API is acting like a catalog of your consumer services. Is going to be the means in which you send and receive data between that external partner. And it's also going to provide some other utility type functions like security, authentication, logging, and monitoring. And so sometimes those utility functions you can actually just do with plugins. So I'm going to be kind of focused around what we're using now. We're using Microsoft's ASP.NET Web API technology. I think it's a really great technology. Not every Microsoft technology is a great technology, but they've done a really good job with this one. So we're going to cover all these areas today. So what's great about the APIs that we're building now is they're RESTful, and probably most of you that are building APIs now want to build a RESTful API. And that's going to be handled by kind of 2 mechanisms. One, you're going to have this controller, and that controller is going to be what takes the action. And then you're going to have some sort of friendly routing pattern that you're going to utilize with it. By the way, here is a great link to a nice resource if you want to build a RESTful API. It's called restcookbook.com. So the controller is really the C of an MVC pattern. So if you break it down, a web API is the controller. And it's basically going to handle all your requests. In the .NET world, they give us this great base class to work from that gives us direct access to things like the request object, etc., that makes our coding very, very simple, fast, and easy. What you do on these controllers is you create public methods, and those are going to be the actions. And the way the routing works in ASP.NET Web API is the method name is going to matter. Your method name is either going to be your HTTP verb, or you can prefix a method with the verb, like get orders. That will mean that a get to the orders controller will be routed through the HTTP get verb. Or otherwise, you can have a method and you can prefix it with an attribute. And I'll show you what attributes are in just a minute. So routing, that's what gives you that friendly URL that you want to work from. So by default, Web API comes with a templated routing engine, so you don't have to do anything. It's built for you, so it's just out of the box. It's going to be config-based. Now, it's in a config, but it's not like an XML config that you can just change on the fly. It's actually something that's going to be compiled. But they're very simple to use. You can have multiple routes hitting the same method, which gives you a lot of flexibility if you want to really change the way your routes work. And every route has to have a template. If it doesn't, you get a 404. So let's look at that in action real quick. And just because y'all always make me look at Ruby or Python, I'm going to let you look at C#. So here, I've got this in .NET. They're called solutions, and this solution has a bunch of projects in it. But this project right here, this is kind of a base API that I built out. You can download it. It's on GitHub, and basically it's to enroll students in classes and also identify their instructors. So it's laid out. You can download the code later. But we're going to look at this controller. Actually, we're going to look at the routing first. So here, just out of the box, I already have a default route. So anything that goes to my URL will be followed by API, and then the name of my controller, and then optionally some sort of identifier. Now, if I just go over here, I'm going to open up Postman. And this is one of the tools I really like to use. So I'm just going to go to, let's go to this guy, API. So we're just going to go to this guy right here. So I'm just going to go to that URL followed by API classes 5. And I'm just going to do a get to it. And I thought I had my debugger on. The other thing about .NET, it's got a really nice debugger, so you can really write code much faster. So here, notice we have this method, and it's a get, so that means the get verb took me directly to that method, and I'm passing in an ID. Now I'm going to make a call down to my business layer, and then I get a response, and then I'm going to build my response. So here I got this class's object back. And then down here, back in Postman, you can see I got my payload. Here's class number 5. So it's a really simple routing mechanism. Now what I can do is I can actually go back to that routing mechanism. And this is just a simple example. Let's say I wanted to make a version just for UTC. So, favorite part when you have to code live. I'm just going to basically paste that one. And I'm going to name this one my UTC route. And instead of API, I'm just going to call it UTC. So I'll go back, and then I'll just come over here. Let me make sure I start it again. UTC. And I'm going to send it. And notice, did the same thing. Took me right back into my get. So that was great. Now another thing you can do is these parameters are optional in the order that they are in. You have full control over all this. So I can optionally also switch the order of these. Stop this. And I can put the ID in front of the controller. Pretty simple. And there's a reason we're going to do that, and I'll talk to you about that in just a second. So let's build this. Hopefully I coded it good. I come back over here, and this time I'm going to put the class ID in front of the controller name. Should do the same thing. Yep. So this is just a really simple example of how routing's done in Web API. So it's really handy, really nice to have. Now, one reason I wanted to switch the order of that ID and the controller name is because I want to try to avoid hackable URLs. And so if you actually had a controller and an actual true key, you put yourself at risk where you might want to come up with some sort of session ID or token that expires, that's encrypted, that you can place in front of your controller name. And that way, it's going to be a much safer way to create URLs. Now, so that's just kind of some of the workings of Web API. But what I want to focus on now is your consumer. When you write a Web API, the most important thing for you to think about is, how can I get someone to consume my Web API? Without consumers, there's no need for it. And if you want someone to consume your API, you're going to have to do some things from the start. First of all, it's got to be easy to understand and self-describing. And when I say self-describing, that means that your controller names, your friendly URLs, and the data payloads that you're sending back or requesting of them have to be very straightforward. You can't make them too complex. And they also need to be a consistent format. One thing that we've learned, and we learned it the hard way, is that most developers are not going to read your documentation. Unfortunately, it's a bad habit developers have, but they're going to try to figure everything out first without looking at the docs. But why? Because we don't read docs anymore. We all go straight to Stack Overflow. Now, unfortunately, Stack Overflow doesn't support my web API. So I have to make sure that I make it as simple as possible for them. So when you think about it, this is the interface. This is, if you're building a website, these are your web pages. Your responses are the I in the API. So what are some things that we can do? Obviously, one of the most important things you can do is when things go wrong, give them good error messages, right? So in our world, our APIs are going to be consumed by an employee at some company. That employee had an employer who chose my partner company who then chose to sell our product. So you've got all these people in between. So when something goes wrong, it goes wrong with that employee. They can't call me directly. They don't even know how to reach me. They don't even know how to reach the partner and their website because it's going through their employer. So you've got all these different layers. So what you need to be thinking about is when you create error messages, think about, hey, my API is probably going to be displayed on somebody else's website, so it needs to be as consumer-friendly as possible. It shouldn't have any industry jargon unless you know that your consumer knows your industry jargon. Also, include error codes. You'll be surprised how many programmers would really like to have an error code so that they can take an alternate action. Hey, maybe if I get this error code, I can take them to a friendly page to recover. Now, there's other useful information you can include. One thing that we found was really helpful was including a version number or a build timestamp. Another thing is the environment name. And I know these sound really, really simple. And you say, well, do you really have to do that? Well, in my world, I have a dev environment. I have a test environment. I have a business acceptance environment. I have an environment that's the sandbox for my partner to develop in. I have a production environment. Then I have a duplicate of production that the employer can use to demo what the employees are going to see. So I'm working with at least 6 environments. And on more than one occasion, I've had partners forget to switch from one of these other environments to production on go live day. So what we want to do is we want to give partners things to help them from making mistakes. If they make mistakes, they get frustrated. So think about them. They're your customer. They're your consumer. So give them things that make their lives easier. So just want to go back, and one of the things that we talked about was that consistent response. So if you look at this response, every single response that's in this web API is going to be the same. So this is the one for classes. And let's go look at the one for instructors. Now, one of the things I included in this little sample project is this project that has a bunch of utility things to help you with. And one thing I have is some classes that help you build consistent responses. So here, this is the response object itself. It's going to have several key things in it. But the most important thing is going to be this section called data model. And in data model, you're going to have this object called return model. And that's where the true data payload is. But there's some other information that's going to be in there. Like, I want my partner to know as soon as they get the response back, hey, was it good or bad? So I'm just going to give them a success or failure. They don't need to know anything else. That's the first thing they're going to hone in on. And then maybe any error messages and, of course, that build time. So let's look at that in action real quick. I'm going to come over here, and I'm going to go to this guy. And we'll just build a good response first. So we've got to here instructors, and back over here. This in. That one in a minute. So here I got a list of instructors, so now I'm just going to create my response. So this class is going to do 2 things. It's going to create a good response and a bad response. And that's how simple it really is. It doesn't need to be any more complicated than that. So I'm going to create my good response. I'm going to pass in a set of links that are links that they could optionally go to. Also, I'm going to pass in the data model and set success. and return OK. And that's all there is to it. So notice I have pretty much the same format here. I have that return model, and then of course my data payload. So again, your response will really make your API successful with your consumers. So one thing that happens now that we didn't have to deal with before is this dealing with cross-origin resource sharing, or CORS. When I first started working with web APIs, it was pretty straightforward because I knew my consumer was always calling me from another server. So it was kind of a server-to-server request. So I could trust you, you could trust me, we knew about each other. But what's happened now in the rich client world that we live in, a lot of my API calls are coming directly from the browsers. Well, browsers aren't set up for that. So what browsers do is they're saying, okay, I'm running www.workday.com. Oh, you want to make a call to api.unum.com. Is that allowable? Because, obviously you're not running within api.unum.com. So what we have to do is we have to make sure that the policies are in place to support that external request. So let's look at that really quick. So in this, I've done a really quick custom CORS attribute. Now, out of the gate, Web API supports CORS, and that's great. I mean, you don't have to worry about it. Unfortunately, it's a pretty weak support. I mean, it's easy to just say, hey, turn it on for everything. But in our world, remember I told you that we want to kind of whitelist our partners. So we want to limit who can access our API. So in this example, I'm going to have value in my web config. Sorry. Hold on. Yeah, it's in here. Yeah, so here, and normally this would be in a database, but for the purposes of this demo, it's going to be right here. So here, I'm going to say, I'm going to allow anybody calling me from localhost or www.adp.com. So in the .NET world, remember I talked to you about these things called attributes. So what I can do, constructors or classes. Sorry, should have had this one already ahead of time. So up here, I have this thing called an attribute. And think of attributes as being methods that get called before a method executes. So it's going to act on that method. So that way you can limit things. So I have this one called enable CORS custom attribute. Find it real quick. There it is. Okay. So here it is in place. So basically what we do is we decorate our method with this attribute. And what this attribute is going to do is it's going to build a policy. And every time this method gets called, it's going to check that policy to see if that URL is a valid URL. So it's going to happen on anything inside that class. I could also put it down at a method level. So let's just run this real quick. Go back to Postman. I not have the breakpoint. A breakpoint here. This is the part you hate about doing a demo. Just put it at the method level. Send it again. Okay, so now it's going to try to build that policy for me, and that policy will be checked every time that there's a call to this method. So basically, it's just going to read through my config file. And so then it added these origins. So instead of just adding star as my origin to my my request headers, I'm going to add origins as well. So I'm going to specifically show watch here. So I'm not going to allow any origin. I'm going to specify the origins that can be sent to this. So obviously this is going to pass because I'm also running from localhost, so I'm running from the same origin. But you can easily see how you can whitelist things. Now, this is where I'm going to give you a quick sermon, okay? So everybody be ready. I'm going to say I'm preaching up front. APIs don't have a UI. So I can't tell you how important it is to start building automated tests from the get-go. Test everything. Automate every single test. You're not going to know all the different variations of UIs that partners are going to put your API in. So you need to make sure your API is as bulletproof as possible. Also, you're not going to find a tester to test your API. Why? Because most testers aren't programmers, and testers aren't going to know how to use a tool like Postman and understand, about response headers and things like that. The other thing is, don't worry if it's unit, integrated, functional, or if you got to hit a database or not. Just test it. I can tell you the benefit you'll gain is far outweighs the architectural correctness of your automated test. It's so easy to build tests. Even if you got to manufacture your own data, do it. A real world example, when you're coding and as soon as you start testing, you find a defect, you can fix it right away. It's nominal. It really doesn't cost your company anything. But now think about it when your API is out in the real world. The example I gave you earlier, say that employer ran across an error. What if, for example, you might be sending down the wrong rates? And so they see one price, but you really should be charging them another. All of a sudden, nobody catches it for a month. Now what are you going to do? Do you want to try to go back to that company and say, hey, employer, we charge your employees the wrong amount? The employer is going to get mad at your partner, who is then going to get mad at you. Then they're going to have to correct their system. Then you're going to have to correct your system. And the next thing you know, you've spent thousands of dollars on a problem that you probably could have caught up front. So again, sermon of the day, automate, automate, automate your testing. Just a couple of tools I like to use. Obviously, you've seen Postman. I think of all the browsers that Chrome's DevTools are the best. They just keep making them better. I know some of you may really love Firebug, but I love DevTools. Fiddler. Fiddler's a great tool, especially when you're trying to test from rich clients, when you're really trying to, look at those response and requests. If you need to do a packet analyzer, Wireshark's pretty much the easiest to use. I've only had to really, really, really use it twice. And both times, I've had a network engineer with me because I can only analyze the packets up to the load balancer, and he had to take it after that. But it's a good tool to use. And there's a ton of free online JSON editors because that's what your response is going to be in, is in JSON. Performance. This is probably one of the cheapest, easiest, simplest things you can do for your web API. On your server, turn on dynamic compression. Pretty much every web server today will support dynamic compression. And if you think about it, every browser out there today can support getting gzip and deflating it. So it's a quick, easy way to speed up your web API. So this is one that always causes a lot of arguments and things in the, with architects and other theorists. The strategy we've kind of evolved isn't really based off of an architectural point of view. It's based off of a consumer point of view. So remember, for us, we want people to build our API. There's got to be some sort of incentive for them to build that API. So whether it be financial or whatever, typically financial, right, because we're all in business. But once they build it, they don't want to spend any more money on it. They expect what they built to work, and they want it to work for a long time. Also, they have other needs and requirements and priorities, so they might be willing to add on to what they've done, but not on your schedule, on their schedule. So we kind of take an add-only approach. And if we do have to version it, we'll version the URL. And the last time we did this, we actually offered out a whole new suite of products. And there was just no way that new suite of products could work with the existing URL. So we basically told our customers, look, we're going to give you 2 years. And after that, you can still keep using the old one, but you can't use the new products without using the new URL. Now, what you can't do is you can't take a stick and tell your customers they've got to upgrade. What you got to do is dangle that carrot. And so fortunately for us, the marketplace helped drive all of our partners to this new URL because they wanted to sell the new version of our products. Why? Because they were better products, they paid better commissions, so there was that financial incentive. Now, did some of our partners wait till the 12th month of that second year to implement this? You darn straight they did. But that's okay. We got through it, and they were happy, we're happy. So again, when you think about versioning, think about your consumer, not about your architecture. Monitoring, log, everything. Every incoming request, every outgoing response. Anything you can think of that will help you identify those. If you've got a session ID, make sure you store the session ID with it. If you have some internal key that you need to go with it, just throw everything together and just throw it all in the database. You don't know when you're going to need it because you haven't realized that you've got that problem out there, but that problem's there. And when you get it, you're going to want to try to solve it as quickly as possible. Why? Because you've got that partner looking at you as like, oh my gosh, we've got a problem. So you've got to solve it as quickly as possible. Also, make sure that you're doing some sort of health monitoring to make sure that your API is always available. Because again, think about how APIs are used. That partner just plugs you into their site, but even that partner is not going to know that your API is having slow responses or is unavailable. And another thing you can do, by doing that health monitoring, if you're accessing your website continuously, it's going to stay loaded in memory and it's going to be quick to respond. Nobody's going to take a hit for that first, have a penalty for that first hit. So API consumers, they want a low barrier to access, they want something that they can implement quickly, and they want something that's easy to understand. Anybody can build and deploy a web API, but building and deploying an effective API is your real challenge. My resources today will be posted on the website, so you can get to them. Again, I've got a couple of sample apps out there on GitHub, as well as the slides for this. Any questions? You want the mic?
Really appreciated your point of view on building things that consumers will actually use. Is that what drove you to use versioning in the URL as opposed to like headers or something like that? Or was it just like, can you talk a little bit more about that?
Well, at the time we did this, utilizing headers wasn't going to be as simple. Now that is a new approach, especially with the REST API, but the URLs are just so much more simpler. It's easy you don't have to worry about anybody and the technology that they're using. You just simply say, hey, here's the new URL. You can switch to it when you want to.
Quick question. Have you done any work with abstraction of your data model from the resources that the clients are working with?
Well, what we do is, so the data model that we present our client is an abstraction from that underlying business model. So they're not necessarily one-to-one. And we always will try to make sure that the data model, that all of the naming conventions used are pretty understandable. Again, try not to make it too industry jargony, because they don't necessarily know my world.
I think you mentioned that a lot of consumers don't read documentation, but assuming you do provide documentation, do you have any recommendations as far as best practices, tools for generating documentation?
We haven't really found a good tool yet, but we always try to follow, like the last API we delivered this last year. We're still looking to see how much we want to invest in writing that documentation, but follow some good sites. Twitter has great web API documentation. I really like their format. The one before that, we actually created our own website, which took months, and that's why we realized, that effort's not worth it. We could be adding more capability.
Mine was actually related to his, and I was wondering what you used for that common lingua franca for doing the APIs with other people. A person who understands different ways of doing things. I end up using curl. I was wondering if you used anything as a standard.
No. Normally what we try to do is, obviously we do give them some base level documentation, but, we have this partner sandbox, and because the way they have to work with our API, we've got to give them a custom data set. We kind of handhold them that first time through that transaction. Then after that, instead of wanting to access us, they pretty much say, leave us alone, we'll come back when we need you. Other questions? Thanks, everybody.
Give Stuart a round of applause. All right, so next week we'll be here, same time, same place. The week after that we won't. We're having the Christmas party on the 15th, 7 o'clock, right here, BYOB. And Andrew here has a quick announcement to make.
Some folks mentioned that maybe not everyone knows about Main Times 24, and this is personally one of the things about Chattanooga that I really, really enjoy. I was at maybe the second or third Main Times 24 before I even moved here, just kind of by accident, came up and happened to run into it. It started out as a little block party street festival kind of thing, but it's really grown to be a lot more. It's 24 hours of activity around Main Street. Starts off, I'll go through some of my highlights, but they have a platform that they used for Startup Week, so you can go through and see all the different events. But essentially 24 hours of programming. There's a chili cook-off that's really a lot of fun. There's Needla's Bakery does lard fried donuts, like old-fashioned donuts that are amazing. Blue Orleans does beignets, New Orleans-style beignets that are amazing. Lots of food, beignet. There you go, sorry. Excuse me. Lots of food, lots and lots of food. There's things like adult big wheel competition race, a big wheel race. It's a lot of fun. So anyway, that's this Saturday at Main Street. You pretty much show up anytime during the day. There's something going on, but you probably want to take a look at the schedule on the website, which is mainx24.com. Fire. I mean, what more could you want? It's fire. Is that it? Thanks for coming out, guys. Everyone, not just guys.